Okay, but how are we going to do that? Well, let's see. So we know theta is an angle, okay, between 0 and 90 degrees, such that cosine of theta is a third. Well, let's form a right triangle with angle theta so that this happens. So we're going to form a right triangle so that this occurs. Okay, well, cosine of theta, right? Okay. So we have this right triangle we could form. Remember, cosine of theta is the length of the adjacent over the length of the hypotenuse. So let me draw a right triangle where the adjacent side has length 1 and the hypotenuse has length 3. From here, you know, this right triangle, no matter what this side is, this right triangle satisfies this condition, doesn't it? Right? Cosine of theta, the adjacent side is 1, the hypotenuse is 3. So cosine and theta I put down here, of course. Well, if I gave you this right triangle, you would see cosine of theta is a third. I hope that makes sense to everyone. But if we want all the trig functions, we need the length of the other side. Can we get it? Well, yes, we can. Pythagoreans theorem. That's what I'm doing here. Right? By Pythagoreans theorem, we have x squared plus 1 squared is 3 squared. Right? The length of the legs squared equals the length of the hypotenuse squared. So from here, we have x squared plus 1. 1 squared is 1 equals 3 squared. 3 squared is 9. So here's what we're doing. And as you can see, right, we want to solve for x, the unknown. So we subtract 1. We get x squared is 8, right? X squared is 8. But what would x be? It's the square root of 8. I simplified it to be 2 radical 2. I would recommend you do that. I mean, it's not hard to do, as you can see. Okay. All right. So now that we have the third side, we can easily get all the trig functions, as you see here, right? This is the length of the opposite side. This is the length of the adjacent. This is the length of the hypotenuse. And we just use our definitions, as you can see. Sine of theta, right, is the length of the opposite over the length of the hypotenuse, right? Opposite is 2 radical 2. Hypotenuse is 3. Cosine is, we said, is a third. We got that already. Tangent is opposite over adjacent, right? Which is 2 radical 2 over 1. Which is just, of course, 2 radical 2, but I left it as this. Cosecant's 1 over sine, so you flip whatever you got for sine, invert it. Okay? For cosecant, right? Here. That's 1 over, you flip cosine, right? You invert that, so you get 3. As you can see. And cotangent, finally, that's 1 over tangent, right? Cotangent's 1 over tangent, which is this. 1 over 2 radical 2. That's what we get here. Any questions on this one? Okay. Okay, let's do another one. So here we have cosecant, right? Cosecant of theta. So basically what I'm saying here is that this is 13 over 12. We want to find all the other trig functions. Okay, now, there's different ways of approaching this. I mean, you could do like what we did here. That is, we can form a right triangle so that the equation holds. Instead of cosine, you have cosecant, and you have 13 over 12. And again, we're assuming theta is between 0 and 90 degrees. Okay? But here's what I'm going to do something different. We know that sine of theta is 1 over cosecant, right? That's, where is it? That's some time ago. Here it is. Cosecant's 1 over sine, right? 1 over sine of theta, we have it's 13 over 12. Up there you are. 13 over 12, as you can see. Okay, so that's what cosecant is. Now, so sine of theta is 1 over cosecant of theta, right? Well, since this is cosecant, we have 1 over 13 over 12. But again, 1 over, what do? You flip it. So you get 12 over 13, as you can see. So 1 over cosecant, right? That's 1 over 13 over 12, which is 12 over 13. So we got sine now is 12 over 13. Okay, so now we want to form a right triangle then, so that sine of theta is 12 over 13. So let's say this was theta, right, down here. I mean, theoretically, you could put theta up here, but the triangle will look slightly different. Okay. Sine of theta, remember, is opposite, the length of the opposite over the length of the hypotenuse, right? So we have the opposite side, the length of it is 12. The hypotenuse, the length of that, 13, as you can see. This side here, okay, that's, again, that side is unknown, right? So I'm calling that x. But how do you find that side? That's easy, Pythagoreans Theorem. That's all you're doing. So how do we get that side? Pythagoreans Theorem. That's what I'm doing here. I'm calling it x. So we have x squared plus 12 squared is 13 squared. So that's what we have here. So that's what we do next. X squared plus 12 squared is 13 squared. So we get this. And then what do? We just solve for x. So 12 squared is 144. 13 squared is 169. Subtract, you get 25, the square, and then x squared is 25, so x is the square root, which is 5. Okay? So that's what we have here. So we have all the sides, right? Since we have all the sides, we can get all the other trig functions, right? I mean, sine and cosecant we have already. For cosine, that's the length of the adjacent divided by the length of the hypotenuse, which is this, 5 over 13. Okay. For cosecant, right, remember that's 1 over cosine, that you flip it, so you get 13 over 5. That's what we got here. Okay, that's good. And tangent, that's opposite over adjacent, right? 12 over 5. Cotangent, you flip that, so it's 5 over 12. That's it. That's all we got. All right. Any questions on that? Like a minute left. That's all right. Okay. I mean, the next one I was going to let everyone try, but I think I sent in the notes already. So because of that, let's just, I mean, I won't be able to finish it, but it's very similar to the last one, actually. Right? Because the last one, we started out with cosecant, which gave us sine. So the only difference here is that we have sine of theta is 1 over 5. So just like before, right, you have to get the length of the third side, right? Since sine of theta is a fifth, sine of theta, right, the opposite hypotenuse, that's what sine of theta is, right? 1 over 5. And then the unknown side, you call that x. You use Pythagoreans theorem. And again, once you get the unknown side here, the rest of it's really not that bad. Right? For x, you get x squared plus 1 squared is 5 squared. So you just solve for x, which is radical 24. And then you just, finish it off with this. Okay. I know I went through that example kind of quick, but it's really just like the other one. So let me stop. We're going to stop now.